So we've got these two rules. We've got the product rule that says if you want to differentiate a product, you're going to take the derivative of the first times the second plus the derivative of the second times the first. And we've also got the quotient rule. Okay, so if we've got this, f over g, it tells us that we can say f prime g minus g prime f over g squared. I don't know. I put the parentheses around there, but it's the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Okay, so let's just see some of these these two rules in action. So let's suppose that we've got 2x cubed plus 3 times 5x squared plus 1, something like that. And we want to differentiate this using the product rule. Well, here we go. We're going to say dy dx here. We got the derivative of the first. Now, so we're just looking at this first function here. Derivative of this first term is going to be 6x squared. Now the derivative of 3 is 0, so that's all we have there. Derivative of the first times the second. Okay, there's that. Plus, okay, derivative of the second. Now, that's just going to be term by term differentiation there. We got 10x. Okay, derivative of 1 is 0, so we've got 10x times 2x cubed plus 3. Yeah. Derivative of the first times second plus derivative of the second times the first. Now, you want to do a little bit of simplification here. You don't want to leave it a mess like this. So I'm going to clear parentheses here, and I get 6 times 5, that's 30. X squared times x squared, that's x to the fourth, plus 6x squared. See that? And then plus this one over here, I clear parentheses over here, and I get 20x to the fourth plus 30x. Okay? Then I add like terms, and I believe that'll be it. So there's 50x to the fourth plus 6x squared plus 30x. And there we have it. There we have it. So that's an example of the product rule. Now let's suppose I change that a little bit. Let's suppose that I have 2x cubed plus 3 over 5x squared plus 1. And I want to use the quotient rule. I have to, right? It's a quotient. So I've got dy dx. Here we go. I'm going to take the derivative of the top, which is 6x squared, times the bottom. Now I do minus, okay, derivative of the bottom, which is 10x, times the top, all over the bottom squared. Now, we're not going to multiply out the bottom. That's rarely a good idea, okay? We just leave the bottom as it is, and we work with the top here. Okay, so let's see what we've got now. We've got 30x to the fourth plus 6x squared. Then over here, minus 20x to the fourth. See? Minus 30x. And all of that over the bottom squared. Okay, now let me add like terms up here. This is 30 minus 20. That's 10x to the fourth. Okay, so I'm going to mark these off as I go along. Plus 6x squared minus 30x. Yeah, I believe that's got it. All that over the bottom. 5x squared plus 1 squared. There we go. And that is the derivative of this quotient. Okay, now let's look at another one here. Let's suppose that we've got y equals the square root of x times x squared plus 1. Something like that. And we want to use the, of course, we're going to use the product rule. We've got a product going on here. Now remember, first thing, change that radical to a fractional exponent. And of course, instead of using the product rule, we could distribute through and use the power rule, but we're practicing using the product rule now. So here we go. If I want to get the derivative, I'm going to take the derivative of the first times the second, okay, plus the derivative of the second times the first. There we have it. Okay, so what I did, you can see what I did. Derivative of the first times the second plus the derivative of the second, which is 2x times the first. Now let's see if we can clean this up a little bit. We've got 1/2 times x to the negative 1/2 times x squared plus 1 plus, let's see what this is over here. We've got 2x to the, 2 halves. This is x to the 1, that's 2 halves. So this is 2x to the 3 halves. That's what this is right here. Just add 1/2 and 1. That's 3 halves. Now let's see, let me go ahead and go a little further. I've got 1/2, and I'm going to distribute this 1/2 x to the negative 1/2 through here. So I've got 1/2 x to the negative 1/2 plus 2. That's 4 halves. Let me just call that 4 halves. Plus 1/2 x to the negative 1/2. Plus 2x to the 3 halves. So see, sometimes the simplification is where you run into a lot of algebra problems. But anyway, we're just chugging along here, seeing if we can make this a little simpler than what we have here. This is kind of messy. We got a little simpler here, and we're keeping going here. So this is 1/2 x to the 3 halves plus 1/2 x to the negative 1/2 plus 2x to the 3 halves. Like that. Okay, now look, I've got 4 halves and 1/2 here. That's 5 halves. So it looks like I've got 5 halves x to the 3 halves. You know, adding these together. This is 4 halves and 1/2. That makes 5 halves. Plus 1/2 x to the negative 1/2. Okay? There we go. So there's the derivative. Now, I'll tell you something I like to do whenever I have a negative exponent like this, and over here I have a positive exponent. I like to do this. Whenever I see something like this, like an x to the negative 1/2, I like to say, okay, I'm going to clean this up a little bit. I'm going to have a numerator and a denominator. And what I'm going to do is I'm going to multiply the top and the bottom by this 2 for one thing, and x to the 1/2 for the other. So in other words, I'm going to multiply everything by 2x to the 1/2 here, here, and down here. So look, when I multiply this first part, so let's think about this. If I multiply 5 halves x to the 3 halves times 2x to the 1/2, let's see what I get. These 2's cancel, and I get a 5. But what happens here? 3 halves and 1/2, that's 4 halves. That's x squared. See? So this first term, just by multiplying by the 2 square roots of x over 2 square roots of x, I get this for the first term. Now let's look at the second term. I have 1/2 x to the negative 1/2 times 2x to the 1/2. Let's see what happens there. Well, these 2's cancel. And look at this. X to the negative 1/2 times x to the 1/2. Well, that's just x to the negative 1/2 plus 1/2. And that's x to the 0. Ah, so really what I get here is a plus 1. See? Because everything cancels out, right? The 2's cancel. And then x to the negative 1/2 times x to the 1/2, that's just 1. So this is how it simplifies. Okay? So that's kind of a nice way to simplify it. Okay, so let's look at another one. Okay, let's look at another one. Let's suppose I've got y equals 2x plus 3. And down here, let's suppose I've got the square root of x. Okay, so here we go. I'm going to recognize, first of all, okay, this is going to be 2x plus 3 over x to the 1/2. And then I'm going to, use the quotient rule. So here we go. I've got dy dx. Okay, derivative of the top is 2 times the bottom. Minus the derivative of the bottom, just using the power rule, times the top. All over the bottom squared. Okay. Now let's see what we're left with here. So I've got dy dx is equal to 2x to the 1/2 minus 1/2 x to the negative 1/2. And actually, let me go ahead and distribute that through while I'm at it. Okay, so if I distribute this through, now you got to be careful. Remember to distribute the negative through. 1/2 times 2, that's just 1. And then negative 1/2 and 2/2, that's just x. Right? 2/2, that's what this is, x to the first, minus 1/2, so that's just x to the first, minus 3/2 x to the negative 1/2. Okay, so I just distributed that through all over the bottom squared. Well, the bottom squared is just x. Okay, so this is what I have so far. Kind of a messy looking thing. So here I'm going to separate things out. I'm going to have a numerator and a denominator. And what I'm going to do, I've got this extra 2. I'm going to multiply everything by 2 up here. And if I do it to the top, I have to do it to the bottom. Now also, I'm going to multiply everything by this. I've got x to the negative 1/2. I'm going to multiply by x to the 1/2 to get rid of that, because x to the negative 1/2 times x to the 1/2 is just x to the 0, which is 1. So look, here's what I'm going to do. Up top, I've got, I'm going to multiply 2x to the 1/2 times 2x to the 1/2. Minus x, I'm going to multiply by 2x to the 1/2. So we're just simplifying now. Minus 3/2 x to the negative 1/2 times 2x to the 1/2. Now, and I'm going to do that to the top and the bottom. Of course, when I multiply the bottom, I've already multiplied by 2 times x to the 1/2. There that is. So I multiplied the bottom by that. But let's see what happens up here. This is going to be 4x, right? X to the 1/2 times x to the 1/2. That's just x. Over here, I'm going to get just negative 2 x to the 3/2, right? See? 1/2 and 1. 1 half and 2 halves, that's 3 halves. Now let's see what else. Minus, look at these 2's, they cancel. And I've got 3, and that's it. See? X to the negative 1 half times x to the 1 half. That's just x to the 0. So this is, now let me go ahead and clean this up a little bit. What I've got now is I've got 4x minus 2x to the 3 halves minus 3. And the bottom is going to be 2x to the 3 halves. See? Because 2 halves and 1 half, that makes 3 halves. And there it is. That's a nice way to simplify it. Now, it's easy to get bogged down in the simplifying. But remember, once you get to this point right here, you've got the derivative. So then it's just, you're just trying to clean it up a little bit, make it look a little bit more presentable. That's all.